Kaman's SMT 9700 high-performance displacement sensor leads the field with its extremely low noise floor and extremely high resolution, in some applications less than a nanometer. The size of a nanometer can be illustrated to some degree by referencing a human hair, which is roughly 90 microns in diameter. If you were to divide a hair into 90,000 slices, a single slice would roughly equal 1 nanometer. We can demonstrate the performance of the Kaman SMT 9700 using this physical test arrangement. We'll measure the deflection of a hollow cantilevered beam by common items of varying weights. The SMT 9700 has been mounted on the base of this test fixture and is connected to a 5U sensor mounted below the free end of the cantilevered beam. This test fixture is surrounded by a plexiglass enclosure in order to help reduce external environmental influences on the beam during our demonstration. Above the free end of the beam is a small platen on which individual items will be placed to deflect the beam for measurement. The SMT 9700 will translate each beam deflection into an analog voltage signal that will be displayed on a computer screen. We'll be able to observe and measure these deflections real-time in units of distance down to micrometers and nanometers. For this demonstration, the SMT 9700 system has been calibrated to a full-scale range of 100 micrometers with a sensitivity of 100 millivolts per micrometer. In our first deflection measurement, we'll measure the beam deflection caused by a common cell phone. We'll set our software screen to display a full-scale range of 10 micrometers. After placing the cell phone, we can observe a deflection of about 3 micrometers. We'll now change our screen resolution to display a full-scale range of 1 micrometer, as we'll increase measurement sensitivity to observe the beam deflection caused by an average house key. Here, we can see the mass of the key deflecting our beam roughly 0.3 micrometers or 300 nanometers. We'll now further reduce our full-scale range to 0.1 micrometer or 100 nanometers. This will allow us the increased sensitivity to measure a beam displacement caused by the mass of a business card. Here, the SMT 9700 is able to measure a beam deflection between 20 to 30 nanometers. We'll now increase our scale back to 1 micrometer in order to show the effects of a temperature change on the beam caused by this simple flashlight. As we can see, simply shining this light onto the top surface of the hollow beam causes enough thermal expansion to deflect the beam downward approximately 0.2 micrometers or 200 nanometers. You may already know that Kaman makes position sensors and systems for literally everything under the sun. Our solutions span the gamut of precision position sensing needs, including displacement, vibration, alignment, dimensioning, and sorting applications. With over 40 years on the job, we look forward to providing a quality solution for you. Call or email us today.